All right, I want to give a quick introduction to the normal distribution and z-scores. And the normal distribution is that nice bell-shaped curve that we're all fairly familiar with. And the nice thing about it is what we're doing here is we're comparing three different types of dinners. We've got a steak dinner with a mean of 1585. And we know that it's a normal distribution somewhere. We're assuming that it's a normal distribution. And the standard deviation is 65 cents. So that means that when we're looking at our normal distribution, the mean here will be 15.65, and the standard deviation is 65. So if I go from this middle out to the point of where it changes from being concave down to concave up, I know that this distance here is 65 cents. So this would be this would be 15 on this side, and this would be 1565 plus another 65 cents makes it 16. What would it be? 1630, I think. And then so what we're looking at, we've got one that charges 1625, so that would be right in this area. So for our steak dinner, our 1625 is going to be just a little bit to the left of that 1630. Maybe it's a little too close there, but this is the steak dinner. And we have a chicken dinner that the mean is 1625 with a standard deviation of 35 cents. So I know that distribution, it follows that normal distribution again, that same sort of bell-shaped curve, but the label on the bottom is going to be a little bit different. I know that the mean is going to be 865. And the standard deviation is 35 cents. So if I go out again to this point where you're changing from concave up to concave down, I know that distance is 35 cents. So that would be $9 here. And this would be $8.30 there. If you go another standard deviation, it'd be 935. If you take that distance and repeat it again, it'd be another 935. And if you subtract another 35 cents, this over here at two standard deviations would be $7.95. And we are looking at $9.15. So that's going to be a little bit higher up here. This is the $9.15. It's going to be in this area. It's a little bit farther away from the mean, a little bit larger value. So relatively speaking, the chicken dinner is more expensive than the steak dinner. The steak dinner is above average, but it's not that far above average, relatively speaking, in terms of the standard deviation. It's not even a full standard deviation, whereas the chicken is more than a full standard deviation. And then the lobster dinner, again, we're looking at a normal distribution. And you might notice here the way that I draw these, it's usually a lot easier to draw that curve and then put in the numbers rather than try to force the drawing of the curve to match your numbers there. We'll smooth that out a little bit. The mean for lobster is 22.95. And the standard deviation is $1.30. So if I add $1.30 to that, if I go to that one standard deviation on either side, if I add $1.30, so this distance in here is $1.30, I'll end up at a value here of 24.25, I think. And if you subtract $1.30, you'll be at 21.65. Would be at that location. We are looking at a price of $23.95. So $23.95 would only be $1 above average, but it's going to be less than that one standard deviation. It's going to be in that spot there. So it seems like the chicken dinner is the most overpriced one. It's more than a standard deviation above the mean. But if we want a more accurate comparison, another way to look at it is we can look at sort of the relative placement. Where is that relative to the mean? And so what I'm going to do is I'm going to look at, how far is the observation away from the mean? Well, the steak dinner we had was $16.25. So if I take $16.25 and I subtract $15.65, let me grab my calculator here and do that. I get a 60 cents difference, so it's over the mean by 60 cents. But I also want to make that relative to the standard, keep getting that thing, relative to the standard deviation, and the standard deviation we have is 65 cents. So if I then divide by the standard deviation, I'll get sort of a relative placement, so it's not just distance, because the standard deviation makes a difference here. I'm getting 0.92 as my z-score. In there is 0.92. So it's 0.92. It's not quite a full standard deviation above the mean. It's just a little bit above the mean there. All right, if we look at the chicken dinner, do the same sort of thing. I'm going to take my observation that the price that I'm looking at in this city is $9.15. I'm going to subtract the mean of $8.65, and I'm going to divide by the standard deviation, which was just 35 cents. So $9.15 minus $8.65 is a difference of 50 cents. And I want to divide that by the standard deviation, because the prices of chicken are closer dinners aren't as spread out as much as steak dinners. So that standard deviation makes a difference. I know it's only 50 cents more, but because the standard deviation isn't as much, I want to take that into consideration. So if I take 0.5 and divide it by 0.35, I get a z-score here of 1.43, 1.428, so 1.43. Usually we round those to 2 decimal places, but of course, the more digits you place, the more accurate you are there. So our chicken is almost a standard deviation and a half above the mean, and that's what the z-score does. Is it tells you how far it is in terms of standard deviations. So this is 1 standard deviation above the mean, 1.43 standard deviations above the mean. All right, and then finally for our lobster, the z-score, if you haven't figured it out yet, the formula that we're kind of looking at is the observation that you're looking at, subtract the mean, and then divide by the standard deviation. Subtract the mean of the population, divide by the standard deviation of your population. So for the lobster dinner, our observation was 23.95. The mean price of lobster dinner was 22.95, and the standard deviation is $1.30. So if I compute that out, 23.95 minus 22.95, are those both 95? Those were both 95. So it's $1 difference. And if I divide that by 1.30, I get 0.7769 or 0.77 for our z-score. So it's a little bit more than a quarter, well, 3/4 of a way, roughly speaking, there for the z-score of the lobster dinner. So relatively speaking, the lobster dinner is the least overpriced. It's closer to the mean than the other two relative to the standard deviation, even though it's a full $1 more expensive, $1 above the mean, because the standard deviation is larger. There's a lot more variation from dinner to dinner, so it's going to adjust those.